come back. So quickly, let's look into this problem here. We have it that we were given that x is equal to 1 over 2 a power n t power m. So the important thing here is to know what each of these things stands for. As you can see, x, a, and t, they were defined to be distance. So x is what? Distance. A, acceleration. T, time. So once you know them, you can solve for anything. We have to determine the values of n and m, the exponents. So quickly, let's solve this fast. Solution. So x is equal to 1 over 2 a power n t power m. Yes, our equation. We focus on the equation. First, you write out your equation. Next, you fix in the dimensions of all these things. X, you fix them in, yes. Ignoring this constant here. Whether it's k or a number, we ignore the constants. We don't use constants in our dimensional analysis. Yes. So quickly, if we do that, x is distance, and distance means L. So I'll change them to their dimensions. S is L. Yes. L. So L will be equal to, I won't use 1 over 2 because it's a constant. A is what? Acceleration. A is what? Acceleration. And that is L t minus 2. Yes. Put it inside a bracket, then fix your exponents. Power n. T is time, and time is t. We don't need brackets here because it's just only t. But if you have something that's not only one letter, one alphabet, you have to include your bracket, that's parentheses. So we have here t is t power m. So let's expand the bracket and see what happens. Let's expand the bracket. This will be L power n. T, here is 1. So 1 times n is n. For t, we have minus 2. Minus 2 times n is minus 2n. Yes. Then t power m. Yes. And here is L. L here means L power 1. Yes. No power means power 1. What next do we do? If you observe carefully, we are dealing with L and T on the right hand side. On the left hand side, we have only L. In this case, we have to introduce T on the left hand side. And how do we do that? We say L, which we know is power 1, will also bring in T. T becomes power 0. Yes, because T power 0 is 1. And 1 times L is still L. No new thing happened. We just brought in T to enable us equate during the time for equation. So this L times T power 0 will be equal to, let's join these two things together. Let's join them. That will be L power n, T power. How do we join powers? How do we join two things that have the same base? We add their powers, law of indices. That will be minus 2n plus n. Yes. So now we equate L with L, powers of L and powers of T. So this we mean, let's say let's make it clearer. For L, let's do L first. For L, this will imply that 1 for L the power, for L equating the powers. Let me see right, equating the power. For L equating the powers, this will imply that 1 is equal to n. Yes. Power of L here is what? N. So this means that n is equal to 1. Now for T, let's use here, for T, equating powers, for T. Power of T on the left hand side is 0. This will mean that 0 is equal to what? 0 is equal to the power of T on the right hand side is minus 2 n plus n. Yes. So this means that if I take m, if I take this one inside now, if I take it inside, it becomes that minus becomes plus. That will be 2n is equal to m. Yes. So m is 2n, right? M is 2n. I have n already. N is 1. Therefore, m will be 2 times 1. So m is equal to 2. Yeah. So in this case, we have to find the values of n and m. Yes. So we are saying that the value of n and m is that n is equal to 1 and m is equal to 2. Let's take more example on this dimensional analysis. So quickly, we'll solve this question. Suppose viscous force F acting on a sphere moving through a fluid depends on the radius of a sphere, r, velocity v, and the coefficient of viscosity eta by the relation F stands for force, K stands for dimensionless constants, the symbol eta stands for viscosity, r radius, v velocity. Yes, find the values of A, B, and C. Find the value of A, B, and C. So what do we do here? It's simple. First of all, we write out the key equation. We write out the main relation that we have. And that is F, let's not have much space. That is F is equal to K eta power A R power B V power C. So how do we solve this? The first thing is to convert each of these things given to us to their respective dimensions. Yes. F is force, viscous force, and force is, I told you, is MLT power minus 2. K is dimensionless, so we will not work with the K. Eta is viscosity. In fact, I'm pretty sure you know dimension for velocity. Yes, it's LT power minus 1. R, radius. Radius means a particular distance, that's length. So here will be L, but you have issue with viscosity. Yes. So first, let me just show you how to get dimension for viscosity. Yes, let me show you. I think I did not discuss that one earlier with you. Let me still show you. So viscosity is equal to force, the formula is force all over area times velocity gradient. Yes, that's the formula. Yeah, so with this we know what force is, we know what area is. The issue now will be velocity gradients. I'll still show you. This is just the v upon the x. Yes, so dimension for v is lt minus 1 and x is l. So here this can take off this. I'll have t minus 1 as my velocity gradient. So that will be 4, which is m lt minus 2 all over area is l power 2, yes, length times length, times this is t power minus 1. So go ahead and combine them together by taking this one to come up. I'll have m, yes, l, l coming up, I'll have, here is 1, coming up I'll have minus 2. So 1 plus minus 2 is minus 1. T I have here minus 2, minus 1 coming up, I'll have plus 1. Yes, plus 1. So coming up it becomes plus 1. Now t minus 2 then plus that one becomes t power minus 1. Yes. So dimension for viscosity is equal to this. Yes. That's it. So quickly, let's solve. So F is equal to K, dimensionless constants, viscosity, radius, velocity. So quickly, we'll fit in their respective dimensions. F is m l t minus 2 equal to K, dimensionless. So we don't have any usage for K. Eta, viscosity, inside the bracket, m l minus 1 t minus 1, bracket close. A. R is radius, and that is length, power B. No brackets for one letters, no brackets. And here we have 3. 1, 2, 3 brackets, 2 brackets, 3 brackets, only 1, like only M, no brackets, only L, no brackets. V will need brackets. That will be L T minus 1 power C. So if I have this like this, the next thing is to do is to open the brackets. First is to impute their respective dimensions. Yes. Disregard the constants. Next is to open the brackets. Open it righteously. Open it well. So m l t minus 2 will be equal to m, all of them here will take a share of the exponent a, and that will be m power a l minus 1. No, we use the power to multiply. Here is 1, I hope you know. I will have a here. Minus 1 times a minus a. T is 17 minus a. Yes. L B. L 1 times C. T minus 1 times C is what? Thank you, minus C. Okay, let's continue. What do we do next? We try and find a means of joining them together. Those that appear twice. For instance, L appeared 3 times. We join them together. T appeared twice. We join them together. So we have M L T minus 2 is equal to M, here is A, L, let's join for L. That will be minus A. We add, how do we join? We add the powers. That will be minus A, this L, this L, this L. Minus A plus B plus C. Yes. Then T, for T, what do we have? For T, we have here minus A. Yes. Minus A plus minus C plus minus C. But plus minus is minus. So let's write minus C. Yeah. Time for equation. We will create first. Equate powers of M. I'm going with M first. Yeah. M, because M is just only one here. Only one thing as the exponent. Just one variable at the exponent. That's why I will go for M first. So this will mean that, here is 1, here is 1, here is minus 2. This will mean that 1 is equal to A. Yes, so A is equal to 1. We've used M to get A as 1. So what do you think we should use next? L has A, B, C. It won't be easy for us to obtain B or C with just the value of A only. But I think it will be easier to go for T first, because T has only 2 variables, while L has 3 variables. So I just suggest we find it will be easier for 2 variables than 3 variables. That's why myself, I will equate for T before equating for L. Already we have A. So C will be easy to obtain. So equating powers of T. So equating the powers of T, equating powers of T. This will mean, it will mean that T on the left hand side, T is minus 2. Yes. Minus 2 is equal to what? On the right hand side, T is minus A minus C. Yeah, minus A minus C. Luckily, we have A equal to 1. So, if A is 1, it will mean that for A equal to 1, this will mean that minus 2 is equal to minus 1 minus C. Yeah, I can say that if C comes over, when C comes over, C will be minus 1, minus 2 going this way, plus 2. So C is equal to 1. Yes. Now we can find B. Yes. So when we now equate, if we equate powers of L, this will now mean that for L, left hand side is 1. Yes, 1 will be equal to right hand side is equal to minus A plus B plus C. Yeah. So 1 is equal to, if I put the value of A and C, which is 1 and 1, I will have minus 1 plus B. It's clear. Minus 1 plus 1 can just go. So B is equal to 1. B is equal to 1. So in this case, ABC is 1, 1, 1. That's the value of ABC. So our A is equal to 1, B is equal to 1, and C is equal to 1. That means that F is equal to K eta R V. Yes, that's the formula. This formula is called the Stokes law. From experiments, K is equal to 6 pi. Yes. So the method for dimensioning is simple, very simple. You put in dimensions of the quantities you have, put them in, put the ones that need brackets inside the brackets. If you're not sure, put all of them inside the brackets. Start equating the powers. Start from the quantity with single variable. Then next, double single variable. Next, double variable. Lastly, 3 variables or more. With this, you can find your ABC. It's simple. We'll give more examples on this to consolidate your knowledge on this dimensional analysis. Once more, I am Holgate Emmanuel.